Do you find sometimes in the situation where you start a new Solidity project and then you don't know what kind of framework you should use because there are so many new ones of them? There's Truffle, there's Hardhat, now there's Foundry, or should it just stay in Remix and just like call it a day and just develop everything in Remix? I had the same problem recently and I heard about Hardhat, that it's like the new thing that you should use now over Truffle, but I have Truffle experience for a long time, so I thought, is it really that much better that I use a new framework over Truffle that I already know and learn something new? Or maybe I should go directly with Foundry, which seems to be the new kid on the block, which is even better than Hardhat, or maybe something else which comes on next. So this is what this video is about. We are going to put those toolkits to a test. We are going to write a set of smart contracts in Remix, and then we bring it over to Truffle. We are going to test all of the functionality of Truffle and see what Truffle can do for us as developers. And then we are going to bring it over to Hardhat. Again, we are using all of the tools that Hardhat can offer us, tests, console, and nodes, and whatnot. And then we are bringing it over to Foundry, which is a new thing. And then we are going to see again what these things can do for us, what Foundry can do for us as a toolkit for us as developers. So let's go. Okay, now what we are trying to do is the following. We are going to deploy an ERC20 token, and we take this from OpenZeppelin. And on top of that, we are going to do a little staking contract. And how that works, or how at least I envision that to work, is that we are going to mint a couple of ERC20 tokens over here, and then we have some sort of staking smart contract that is going to convert this to other ERC20 tokens based on a conversion rate, and that conversion rate is going to change over time. So the more time passes, the more the bigger the conversion rate is going to be. So you need more of these initial tokens to convert them to the staking tokens. And let's call this one, I don't know, let's call this our TOC token, and that one our stay token, our staking token. And I'm just doing that as an ERC20 token, so you can also import it to MetaMask. But that's totally not important. The important part is we are going to do this first of all in Remix, just to get started with a simple prototype. I'm going to play a little bit around in Remix. Then we are going to port it over to Truffle, and then we are going to port it over to Hardhat, and then we are going to port it over to Foundry. And then we just have a look how this works and if it's any good and if we are happy with it, or maybe not. I don't know. Okay, let's get started. And I have over here already opened the OpenZeppelin website. I just want to show you what I'm going to do. I'm going to import this ERC20 token into Remix. And I think there is already a workspace for that, so we can make use of that. So we're just going to use this ERC20 token. So we're actually going to use two of these ERC20 token. One is going to be a normal standard ERC20 token, transferable, and everything is going to be fine. If you have those tokens, you can transfer them from one account to the other. You can add a liquidity pool on Uniswap if you want, and you can add allowance, and all the functions will be there from a standard ERC20 token. And then the other one is also an ERC20 token, but we're going to add a couple of functions in there. Number one is you're going to add stake and unstake, and that is going to transfer the tokens from one account to the other. Maybe we have a tight integration with the other one and we add some access control. I don't know about that yet. We can figure this out as we go along. And what we want to do as well is before token transfer, so we don't want to allow transfer from the token unless you have a specific transfer role, or I don't know, some time constraint is there. We will see that as well. So I haven't fully figured that out, but we're gonna just figure it out as we roll along. Now let's head over to Remix, and I'm going to create a new workspace over here. And I just saw that there are actually templates that we can use now, and I'm going to use the OpenZeppelin ERC20 template, and that will conveniently give me, first of all, a sample ERC20 token. We'll just download the npm package over here and build the artifacts out. And then it has, where is it? Where did I see that? It has to deploy with Ethers.js and Web3.js, or in this case, it's going to be TypeScript-like thing. Not sure if that's really TypeScript. I'm somehow missing the types here. But okay, so let's say it's TypeScript because it has a TS ending. And what it gives you is basically a deploy script to deploy those tokens, which is very convenient. So you don't have to head over to the deploy and run transactions tab and select the right contracts and so on and so forth. You can just right click, run, and it will deploy the tokens. Now that's not what we want, because if you have a look into the token, then you see it's a sample ERC20 token. It's the token name and the token symbol. We want a couple more things, and that is we want, first of all, a total supply. So let's give this a uint total supply, and we are going to call mint, and the mint goes to, where is the mint going to? npm OpenZeppelin contracts token ERC20 sol. There is a mint function, and that mint function gets an account and an amount. So let's just go in there. Mint, that is going to be the message sender, is getting all the tokens, and we are going to give it. Okay, so it's going to mint the total supply. Now we have to supply it also into the deploy with Ethers.js. So we are going to give it here. Let's just save this and rerun it from scratch. Let's rerun this. My account here has all of the tokens, I hope. And if I am funny, then I can send the tokens over to another address, transfer to over here. And let's say I'm transferring this guy 50 of my tokens, and that all works fine. So I have less and the other guy has more. No need to really test it, but just in case you're interested in. Okay, so we have a little test token. It's called test now. We obviously want to call this talk, I said, and that's it. So this is our first token. It can be transferred. Yeah, the initial mint is going to the deployer, and now we also want to set up and same token with mint functionality. So let's just see if I can copy this, and paste this over here. Does this work? Paste. Do I get another one? Oh yeah, I get another one. Let's right click, rename, and then sample staking solidity file. That went somewhere else. I don't know where this went. And let's make this a little bit bigger so you see something. Okay. So in the second one, we do not have a minting. So there's no mint here. And there is also no total supply because it's 0 at the beginning. But there is a stake function, stake. And that is going to be the amount. And then we have a function unstake. And that's just making this very crude now, just to see how that works. And we obviously want to avoid the transfer of these tokens. So what we have to do is before token transfer, we have to implement that function as well. What is that? Internal? I think it's internal. Not sure. Is it internal? Internal. Why you don't like me? Oh, function, of course. Function. Oh, override, yeah. Are you happy now? Internal. Okay. And then we are going to revert here. Staking transfer is not possible. And I could do a custom error message over here. Yeah, cannot use any of the variables, but the transfer is basically not allowed. But I can mint tokens and I can burn tokens in the name of a user. So what we're going to do is we are going to have an initial timestamp over here. Let's call this our uint public deploy timestamp. So we know when we deployed. And then we can do something like a conversion rate. And ideally, what I want to do here is that, like if you have a time, as long as time passes, at the beginning you get, let's say, one staking token for one of the test tokens, the staking token for what did we call it? Talk. But after a while, as time progresses, you get less. So after a while, you get only 0.5 staking token for one of the tokens. And then this goes on and on and on and on and on. And so, I mean, it's not production ready. You have to do your own kind of contract over here. I'm not doing a bonding curve or something. I just do a simple kind of incorporation of the time that passed between the deployment of the smart contract and wherever the user is trying to make a conversion or stake. Let's give this in talk amount, just to be clear here, amount in SDA. And the conversion, we are also calling different. We are calling this amount in SDA, so that we know when we put talk tokens in, we get SDA tokens out, and the conversion rate is going to be amount in talk, not multiplied, divided by, let's say, the block dot timestamp minus deploy timestamp. So that would be the seconds, since that is past, but we don't want to do seconds. We want to let's do it by hours. Is that a thing here? Was it hours? Hour? Hour? Yes, hour. So in the first hour, you get the same full amount. In the second hour, you get half. In the third hour, you get 1 hour. The thing is, the math is really not that important. It's about, for this example, obviously the math is important if you run this in a production environment, so you shouldn't make any mistakes here. It's pretty late here, and I just need an example to show you the interaction between two different smart contracts. And for this one, we are just having a conversion rate over here, and we are going to have a conversion rate over here that basically multiplies that. And I really don't want to spend too much time on doing the math. But what I want to spend time on is the contract interaction, because now we need some way of transferring the tokens over. And in this case, we cannot really transfer the tokens over. We have to have some way of generating the tokens, because you cannot generate tokens out of nowhere if you're not in control of the smart contract. You need to be in control of the smart contract, and that one means that you have to have access to the mint and burn functionality. And to do that, first of all, that's called our staking token, and then this one is called our sample token. Let's also rename this. No, F2 is not working. We have to click here, rename sample token. Why is this popping up here now? What is that now? Do we have two files now? I don't know. Remix is not ideal for smart contract development. That's something for sure that I can say now. And this one we can call staking token. Okay, so we have those two, and we somehow need access to the smart contracts low-level mint and burn functionality, and one of those is we need to give our staking token access to the sample tokens mint functionality and burn functionality, and we need to give our, well, we need to burn and mint inside the staking token. So one thing over here that I want to do is I want to introduce the access controls. There is a very simple one with ownable, but I don't want to do that one. I want to use the access control, this one over here, copy that, paste it over here. And let's add some roles over here. Mint rower. And then a burner rower. And then we are going to have the function mint address 2, and then a uint amount public, and that one requires is obviously also from the access control type. Has a rower, and that is the mint role message sender. Just add a simple error message over here, and if he has the mint role, then mint for to the amount. See if that compiles. That compiles, and then we are going to add also the burn functionality. And then you don't have the burner rower. Burn. Okay, so somebody or something can get the mint role, and if he has the mint role, then you can call the public interface to mint something. And if you have the burner role, you can call the public interface to burn something. And now somehow we need to make use of that in our staking token. Let's import the actual token over here. That is the sample token. And then we need to get the address over here for our sample token. And then we're gonna set this during deployment of the smart contract, just because we can. And then over here, we are going to stake. That means we are going to burn in our sample token from the guy who called this. We are going to burn the amount in toke. And over here, we are going to mint for the guy who called this the amount in STA. Great. And over here, we are going to, well, we are going to mint for the guy who called this the amount in toke. And then we are going to burn for the guy who called this the amount in STA. Okay, let's give this a ride and see a couple of things that we have unreachable code somewhere and whatnot. Well, let's give it a try. So instead of running the script, I just want to run this manually for now, just to see if it works and see if we can deploy our sample token. We have a token name that is sample token, then a typo, then we call this toc, and we give it a 5,000 token total supply. Transact. That worked. That one was the old one. That one is the new one. So we have our AccessControl directly integrated into the token smart contract. Might not be the wisest thing. I don't really care at this point. I just want to have it done. And if I call mint now, then I should get an error message. Let's just call this. Well, of course, I cannot call it without arguments. Let's call it with an argument. So I get an error, and the error is that, where's my error message? I don't have the minter role, but if I call it from our staking token, then I should be able to do that without any problems. So I'm going to copy our address of our sample token, and I'm going to our staking token, and I'm going to give this a token name, staking token, STA, and the address of our sample token. So that one is deployed. Where is it? Where is it? Over here is it. Perfect. And we can now stake. Let's stake, I don't know, 100 tokens. Oh man, why it didn't work? So it didn't work. Why it didn't work? Oh, how convenient. There is a debug button in our remix. And that is one of the major benefits of using Remix. You can directly debug into the transaction if you want. And I think this is one of the big, huge selling points of Remix. So let's just see what happens over here. So we can directly see what are our locals. we have now a division by 0 is something that is just not being shown here. So why don't we fix it? So amount in top plus 1. Let's see if this works now. So we have our staking token. We just need to redeploy it and give it permissions. Now, we didn't give it permissions yet, but I think it stopped before that. So let's go to our normal sample token. We give it a staking token 2 STA transact. Let's see if we can, with our new staking token, actually stake 500. Oh, you don't have the burner role. So this is a totally different error message now. That means our staking token contract doesn't have the actual role to do something, but we fixed our division by 0 error, which is a good thing. Let's proof grant role. Role is going to be, that's a little bit tricky. The role is the Kesa cache of the name burner role. So in this case, we can go to web3.utils.sha-free. So that is our burner role. I could also call the actual, where is it? Function over here should be the same. 539, yes. So let's just grant this role. So what we forgot is to set up the default admin role. And we have to do this over here in the constructor. So our, where's the default admin role? The default admin role is coming directly from the AccessControl smart contract. And now we have to do everything from scratch, but I'm not going to do that. We are going to delete everything and we are going to script the stuff. So what we want to do first is deploy our sample token. Then we want to deploy our staking token with the sample token's address. And then we want to grant the roles to our staking token that it can mint and burn inside the sample token. So let's get this done. I'm going to open deploy with web3 DS, and we are going to take our sample token and we call it sample token talk, and it has some supply, initial supply. And then we are going to take our staking token staking is await deploy staking token. Staking token is the token called, and then we call it stay, and then we give it the result address, and that is fine. And then we are calling on the sample token the grant role functionality. But before we're going to do that, let's just see if this runs here. Run. Oh, my gas limit. Okay, what is going on here? So we guess we just give it 15, or is it 1.5 million gas? Where's the gas coming from here? Deploy.
arguments, and then from, and then gas. Let's give it a little bit bigger gas limit. Okay, do we have 2 tokens here now? What is this? Nobody knows. Okay. SampleToken, StakingToken. Are we the admin? Where's my grand role? Over here. Grand role, Minter role. So the role ID is this one. Our staking token contract. Our staking contract is this one. Okay, that's fine. And then our burner role is this one. So our staking contract has the roles now, and we can maybe now stake. No, we still cannot. Staking transfer is not possible. Okay, so we have another bug in there, but before we're going to do that, we are going to use our smart contract over here in the script to actually grant the roles, so we don't have to do this again. If you're going to fix something, it's getting better and better from here. How are we going to do this? Just get the whole contract instance. Why do I need to get the options over here? Why is that so stupid? I just want to have the whole contract. Then I can directly do, can I just rename all of that? Can I rename that? I cannot. Okay. Sample token options.address SampleToken options.address. Who made this? Doesn't really matter. Let's just use it. SampleToken.methods.grant row, and that is await SampleToken.methodStart.minterRole.call, if I'm not mistaken, and then we want to do this on result staking.options.address. So we want to give the staking contract the minter role, and we want to give the staking contract also the burner role. I think we have to do an wait here, and then here at dot send. And now kill me if that works. Grant role, how is it called? Grant. Oh, grant with a T. Okay, run this, and it's deploying, and no from field. We have no from field here. Okay, we can fix that very easily. We just go back to our Web3. This is the Web3 provider. Amazing. And then we just get the accounts because it's already conveniently over here. We just go back to our deploy script, accounts, and then we just say from accounts 0. Let's see if that fixes our problem. Hey, I think we solved it. So let's just kill all of that, and let's just rerun the script. Let's see if we have. Do we have a balance? Balance. Yeah, we have a balance. Can we stake? Is it the same error message? Oh yeah. Transfer is not possible. Perfect. So the last thing that we want to do is we want to allow the I think the from or the to address must either be a burn or a mint. So from is address 0 or to is address 0. Otherwise, the transfer is not possible. So you cannot transfer it anywhere else. Oh, and then we obviously want to call the super before token transfer from to amount. Perfect. Now we can kill all of that again. We don't have to run through these things. We can just go to the script, run it, and we have our 2 token contracts over here. And let's just take 50. Hey, how much do we have now? What is the total supply? Total supply is 50. Perfect. Let's just see. What is the balance of this account? That is 50. Now let's unstake. Unstake. 50. Yeah, that looks good. Let's see the total supply over here. No, everything's fine. We just have some random magic conversion rate, and it took about an hour in Remix, and we used the debugger, we used the scripts. I had very little idea that these scripts are already in there. I never used them before. I still don't like Remix too much because, you basically don't have a real IDE. You have to right-click, rename, and a lot of things that you're used to from VSCode and from other local desktop environments that I just enjoy a lot more. Other than that, yeah, I think Remix could be one day, maybe, a good IDE, but I don't think that it's going to replace my VSCode anytime soon. So let's take this example. We already created a token. I don't have to create it from scratch. I don't have any tests in here yet, and I'm not exactly sure how to write these tests in Remix. I see that there are solidity tests. I'm not exactly sure how to start them. That's kind of my problem. Maybe I have to look it up. I don't know. But definitely, we can run at least 1 or 2 tests in Truffle. We can run 1 or 2 tests in Hardhat and 1 or 2 tests in Foundry and see how that works with the deployment. One thing that I would have to do here now is I would have to go over to my, injected web3 provider with MetaMask, deploy the smart contract, and then probably gonna flatten it. Flatten, is that even working? Flatten. What's gonna happen with flatten? Yeah, whatever. Yeah, just trust this thing. Okay. So it's gonna flatten the whole thing, and then I can upload it to Etherscan or to other block explorers. And I'm not gonna use this in Remix. And I would also at this point not gonna use Remix anymore. So we're gonna bring it over to Truffle, and then we're gonna see how it works in Truffle. to a local development environment, because I'm not a huge fan of using Remix for large projects. Not that this is a large project, but you know, at some point we might want to extend the whole thing. So what I'm going to do now is, because I'm here on Windows, and I just recently upgraded to Windows 11. Not a huge fan so far. It's not a huge difference to Windows 10 anyway. But rounded corners are not my thing. Anyway, so I'm going to create a new folder in my, this is a Ubuntu, so in case you're just wondering, this is a Ubuntu running on WSL2. Nothing special about it. It is included in Windows, so I'm using the Ubuntu here, that if you're on Linux or if you're on a Mac, your terminal should be pretty much the same. So I'm going to make a new folder for, what are we calling this? Local dev test. Okay, now code. So I'm going to open this in a VSCode. Just bring this window over here. So everything is a little bit small. Let's make this a tad bigger. And we are going to get started with Truffle. So just in case you're wondering, I'm also bringing this over to my website, Ethereum-Blockchain-Developer.com, and you will find the whole walkthrough and videos over here in the advanced mini courses. And I'm probably gonna call it Remix versus Truffle versus Hardhat versus Foundry. What an exciting name. Okay, so let's do this with our IDE over here. Perfect. Let's get started with Truffle. And I'm doing each one in a separate directory so that you know where things are. So I'm going to into Truffle. You have to install Truffle, obviously, first. npm install -g Truffle. That will install Truffle globally. I'll just pause the video and come back when it's done. And maybe that's one of the big differences to Hardhat, or maybe that's just me that uses Hardhat like that. I'm using Hardhat as a dev dependency in a project. So I could potentially use Hardhat also inside a Truffle project, which works fine. Hardhat has a couple of plugins to do so, but Hardhat is used as a dev dependency, and Truffle, I usually use it as a global kind of installation in my environment. Not sure if other people are doing that differently. I used to use it like this, and I think that that's the recommended way to do it. At least since I started with Truffle version 3, it was always a global installation. So maybe that's something that changed. So if so, just let me know in the comments down below, or find me on LinkedIn or Discord or wherever else you might want to get in touch with me. While this is building in the background, let me just show you a new plugin that is now available from Truffle for VS Code. You can install it. I haven't tested it yet, and I will not test it on this video either. But if you are interested in some sort of integrated development environment directly with VS Code, then that's maybe a thing for you. I very much like my Truffle to be accessible via the command line. I'm also not a huge fan of the Git integration in VS Code. I very much love to just type in, git commit, git add, git pull, git fetch, whatever. So I'm not a huge fan of that either. And I like to have my Truffle config manually changed. So maybe that's just me, or maybe that's because I'm used to that. But I would definitely go that route, because UIs change and then suddenly a button is somewhere else where it's not supposed to be. So let me just close that one over here. Let's go back to the Truffle empty folder. And then when you have installed Truffle, then you just type Truffle in it. And you have a new Truffle config, which is basically it's everything in there that you would possibly need. It's currently with Solidity version 0814 pre-configured, and it just has the migrations contract, no tests, and only one initial migration. In case you don't know, Truffle is working with migrations management. So they have their own migration smart contract that manages which smart contracts were already migrated to this particular chain. And then you manage the migrations with this JavaScript files. So let's just add in our sample token and staking token. I'm just, instead of copying this over, I'm just having sample token solidity, and we have the staking token solidity files, and then we are going to copy over. What did I do now? So let's Control C. That one was the sample token, and then we have the staking token. Okay, now we have those here. And one thing that is different to Remix right away is our OpenZeppelin NPM dependencies are not going to be injected automatically, so you have to install them. If I run now Truffle Compile, then it will download the compiler, and then it will just fail because it cannot find the OpenZeppelin smart contract. So what we have to do is npm install OpenZeppelin, I think it's contracts if I'm not mistaken. And it's going to go here to the node modules folder, and I just see Truffle also doesn't init a new npm project or node project, npm init-y. Let's just initialize that and then save the contracts to the package.json file. Now we should have them over here, the contracts. And if we are going to Truffle Compile now, it's compiling, and let's have a look what's going to happen. Yeah, it's compiling the smart contracts, and they go to a build folder and a contracts folder. Inside the build folder, be careful with VSCode over here. Sometimes people are wondering what is they make mistakes with the folder structure. Anyway, so we have our build artifacts here, and if we want to deploy them, or in this case with Truffle it's called migrate them, then we use this migrations file. So I'm just going to copy this one over here, type it to SampleToken.js. What you want to do here is we want to deploy the sample token. And the way this works is it's getting the artifacts from the contracts folder, and then it is going to deploy those over here, and over here as the second, or as the parameters, are going the arguments from the constructor. So if we go over here, sample token, then we have the token name, token symbol, and total supply. Token name is a sample token, token symbol was TOC, and the total supply, let's just give it a, I don't know, a few 100,000, and then we need to deploy it somewhere. And there's a couple of things that Truffle does for us. One is it has an integrated development environment, so, or a development chain. If you're gonna type in Truffle develop, then it will open a test chain with a console attached to it, and then we could do migrate, and then let's just fingers crossed that this works. It's going to compile the smart contracts if they are not compiled yet, and then it's going to migrate them to this test chain using the accounts that are here with, I think it's 100 ETH each. So if you have the console open and you have it deployed, then you can do something like this. You can say that token is await sample token dot deployed. And then you can interact with your token like it is a JavaScript object that can interact with it, just like calling functions. For example, I can call the burner roll, and then it will just give me the burner roll function from the public constant that we defined inside the smart contract, and you get all of the other functions over here. That's a little bit different than Web3.js, and I'm not sure about Ethers.js. I haven't used Ethers.js too much. With Web3.js, you would have the methods inside the methods array, and then you would call the methods there. I'm not sure if that is possible here. I don't think so. No, that's not existing. And yeah, that's different. That's Truffle Contract, which is an abstraction of Web3.js and an overlay, and then it will internally call Web3.js functions for the smart contract instance. Well, enough of that. I'm sure you didn't come here to get a full tutorial on Truffle. You just wanted to know how to actually run those things. So we have the sample token, and then we have the where's the free staking token. And to bring this over, we want to, where's the script over here? We want to deploy it with the sample token address. So we go to the staking token. I'll deploy the staking token. And we're gonna give it the sample token address that is gonna be sequential, the deployments. So if we have here the sample token as the inside the third migration, then the sample token from the second migration is already deployed. So we can call over here sample token dot address, I think. Let's give it a try. Truffle develop, migrate. Well, it seemed to have worked. And the last thing that we need to do, we need to bring over the grant roles on the sample token. So we just copy and paste the huge thing over here. Deploy staking token, and then the staking token is deployed, and then staking token is the staking token not deployed. Oh. So we are going to grant a role on the sample token with the minter role. And Truffle can figure out on its own if it's a call or an actual transaction. And then we want to have the staking token dot address, and we don't need to send over here because Truffle is figuring out on its own what is the correct address to send from. Okay, let's migrate and reset this, and you can guess already that I've done this a couple of times in my life. So of course this must be an async function. Migrate from free to free. So we're going to migrate only the third migration. Well, that seemed to have worked. Let's just see if we can run the first test on it. That would be let staking is await StakingToken.deployed. And then we want to stake 50. I must have forgotten something somewhere. If we compare this to our remix deployment, then SampleToken, you do not have the correct address. Why don't we just go in and we debug this? So we can just type in debug 0x57a, and I'm doing this all the time. Something happened and we're gonna start a Truffle Debugger. It's a step-by-step debugger, very similar to the one that is in Remix. So we just go in step by step, we stake, and when we type in V, then we can have a look at the variables, and the sample token seems to be the correct address. And why don't we have okay, let's jump to the sample token, and I might have forgotten here. And wait, that is very much possible. So let's just restart the whole thing and see if it works now. Getting a little bit fed up here, and I'm still hoping that this works better with Hardhat or Foundry. I don't know. I never had any issues with Truffle so far, and of course if you try to make a video you start to get issues. Okay, well, now it worked. Okay, basically the deployer is a promise, and that promise didn't resolve, but it also didn't give us any errors. So we used the debugger. I showed you how the migrations work. Now let's write a simple test that does exactly that, staking, and we would expect to have logs back. Let's write a test StakingToken.test.js. Now we can basically do the same as we did in the migrations. Const staking token is artifacts dot require staking token. And what is different to the other testing libraries, instead of with Mocha, instead of describe, you use contract staking token, and this would make sure that on each contract it would redeploy the smart contracts. And then over here we get some accounts array, but we don't really need to use that. And we want to have it, not if, it, damn it, it is possible to stake 50 token. And then we just write an error function over here. And here we can basically get access to our staking token. So let's say const staking token, that's the instance, await staking token not deployed. So basically the same thing that we did in our console. And then we say result is staking token dot stake, and we want to stake 50. And here we can use the assertions. For example, we could assert, look at our VSCode, equal that await staking token dot balance of our account 0, that's the first account in our accounts array, is basically 50, but with 18 zeros. So let's just console.log this just for now, and just see what happens. Just make it toString over here, because that's a big number object. Okay, let's just dot exit or Control Z, Truffle test. Oh, somebody loves me today. Truffle test. Oh, we don't have a dev environment. We can use two things. Actually, let's just use Ganache in addition to that, because that's the official client for Truffle. npm install Ganache CLI. Install that globally. Like pretty much anything in the Truffle ecosystem that you want to use is installed globally. What is going on here? Oh. Is it just called Ganache now? Yep. So it's descending on 8545, and in our Truffle config we have to enable this network. So let's just run Truffle test again. And it's connecting to localhost 8545, deploying the smart contracts, running those tests, and we have 0 tokens staked. That's interesting. Shouldn't be the case. Staking. Why is that 0? Oh, because that's a promise. So how about now? And as you can see in every test, I mean, that's clearly, hopefully the same thing with the other frameworks as well. In every test, it's going to redeploy the smart contracts. So we have a so-called clean room test. Alrighty, so we have our 50 tokens, and what I like to do with Truffle is I also like to use a different library called Truffle Assertions. With Truffle Assertions, you can basically require Truffle Assertions, and then you can say event emitted, or you can, well, see that something is not emitted and so on, instead of like doing weird if-else structures. And I'm going to install that now. Truffle npm-e npm install Truffle Assertions, and then we can just use it over here. So everything is kind of like neat and tidy. So we are awaiting Truffle assert event emitted, and the event is going to be what kind of event did we emit here? Transfer. Let's have a look how this works. Event emitted result. Okay, we want to await here that 50 are staked and the transfer event is emitted. Let's just see if that works. Truffle test. And it's passing. Let's see the other way around, that it works, that something is not emitted. And we see there's a huge error. Event of that transfer was not emitted, and we can immediately see that something went wrong. And then we also want to assert assert equal that this one to string equals this string. Let's test this one more time, and then also make the other way around, just to make sure that we covered everything. Okay, we have transferred 50 token. Let's see that this one equals 500, so this one must fail now. Let's see if this works. It's not. It's expecting 50 to be equal 500, so that doesn't work. Okay, so we have our contracts, we have our migrations, we have our tests, and we have it in Ganache. Let's just now connect our MetaMask to Ganache and see if we can find our tokens in our different two smart contracts. I mean, that's obviously the thing that we want to do. This is why we set up two different contracts. So Truffle migrate network development. So we're going to deploy this to our Ganache over here. Ganache is listening on localhost 8545, and then in a second I can show you with Truffle that this works. The only thing I have to do is I have to import the private key. That's pretty annoying. Let's just restart Ganache. Copy the private key over here to my MetaMask. Use localhost 8545 and then import account with the private key. Okay, we have 1000 ETH, and then we are going to deploy that, and then we are going to use the Truffle console on the network development, which is the standard network. Actually, you don't have to give it a name. It's by default the network development. We are going to use the network development to actually stake something. Stake 50. Okay, fine, this worked. And now we are going to import our staking token and our sample token into MetaMask as an asset over here. So import tokens, contract address. So it knows already that we have a little bit of tokens. Obviously, this is 18 decimals. So we have a little bit of our tokens. It's not going to be a full token. I made a couple of mistakes here with the 18 decimals, but let's just go over here, import the other one, which is this one. So, oh, come on, show me my two tokens. Great, how much do we have? We have our SDA tokens over here, which is just 50 or 5 in this case, because the last decimal place is missing. And we have the talk, which is now 50 less than before, or just shows 5 because the last 0 is not really important because it's anyway a decimal place. Okay, fine. So we have, what do we have now? Okay, in Truffle we have a couple of things which is really cool and actually kind of standard right now. We have the migrations. Which deploys to our Ganache or deploys to any other network. Then we have the tests, which works on an internal network, or if you want to on Ganache or any other network. Then we have a console, which we used where we can interact with the smart contracts. And then we have a debugger, which is a step-by-step. And then we have, obviously, outside of the ecosystem somewhere, but we have Ganache, which is a development chain, and there we attached our MetaMask to it. MetaMask. And then we saw our tokens pop up, which is a nice thing because they have a standard interface. Okay, that's what is possible with Truffle. Now let's do the same thing again in Hardhat, because we can. Okay, let's close our Ganache and let's close our Truffle here, and let's just create a new folder that is called Hardhat. And in this folder, we are going to start from scratch with the same project and the same kind of things. So we are going to Hardhat, and I'm closing this other console over here. And what the first thing that we need to do is we need to install Hardhat. Well, Hardhat is installed as a dev dependency over here. And then we can run npx Hardhat. And what it brings up is a basic console. And we create a basic sample project. We do it in this folder. Here we add a git ignore, and we're also installing all of the sample projects dependencies. That is the waffle and chai and ethers. So let's do that. It's going to take a little bit. I'm going to pause the video and I'm back when it's done. Alrighty. So Hardhat has finished installing all the packages that we need, and I've already opened up the Hardhat config.js file, which is in this directory root over here, which is, well, configuring Hardhat. And the rest of the directory structure is very similar to Truffle. It is a contracts folder. There's already a contract in there, more on that in a second. Node modules folder, scripts, which are scripts to actually do something, deploy it or configure something. And then we have tests, which are very similar to the Truffle test. It also uses Mocha, but with the difference that it actually stays with the default describe function of our testing framework. And it uses ethers, not Web3, but you can use Web3 because Hardhat uses for everything plugins, and there's tons of plugins. You can actually use Truffle and Hardhat together in the same project if you want to. Okay, let's have a look at the Hardhat config. In the Hardhat config, you have to require the plugins that you want to use, and you can define tasks. And we see that Solidity version 0.8.4 is configured for this project. Now, without doing anything further, we are going to import our smart contract in a second, but let's just run the test over here. Actually, let's run the task first. npx Hardhat. You can see it opens up it opens up the help page or the command options that you have with Hardhat. And we see available tasks is the accounts task over here. So let's just run this npx Hardhat accounts. So it brings us a list of accounts that we have here with inside Hardhat. Ethers also works a little bit different than Web3.js. So if we go into our script, then you see that in our main function over here, we get the greeter, and that is by getting the contract factory. So, and then we're going to deploy it, which is calling basically, the constructor with the argument. So if you go to the greeter, then we have a constructor with one argument over here. And that is actually a Console.log, which is a specific thing or a specific feature from Hardhat, which a lot of people love, that you can just log some output anywhere in your smart contract code. I still think it is not as feature rich as a full-blown debugger. Obviously, if you come from a JavaScript world, this is like the thing that you really want to use, or you really used to from JavaScript, because console logging is something that I think you learn it in the first half hour where you write your JavaScript code. Console log is your friend. So it was a great move to have the console log inside Hardhat. To run the tests, all you really have to do is run npx Hardhat test, and it will launch the test within its own testing framework, on the compiler, compiling the thing, and then testing the smart contracts. Obviously, it's pretty quick, but more on that in a second when we have brought over our smart contracts from Truffle to Hardhat. Okay, by default, when we are running this test and you're using an in-memory network, very much like the Truffle development network, if it's not even the same, I think it's the same. I think it is importing from Ethereum.JS VM and EVM implementation, and I think that's the same that is importing also in Truffle. But very much like Ganache, Hardhat has also its own node, and then that one looks like this. It gives you very much like Ganache 10 or actually 20 accounts, because why 10 if you can have 20 with private keys. And let me just split this console over here. And when you run npx Hardhat compile, then Hardhat will compile the smart contracts. And what I meant before is you have the greeter, and inside the greeter you have console.log statements. So if we are running npx Hardhat test network localhost, then we should see the console logs over here, which is a really nice thing because they are outputted no matter if the contract call is successful or not. So you have those console logs, which are a big help, and everybody loves them. And even if the contract fails, let's say we cannot set the greeting because we have a require false, does not work. Let's just see, we have this one over here, and we test this and it fails. Then you should get a VM exception, but it tells you exactly where it fails. So it fails over here, they require false, but you cannot really dig into it, but you can console log everything. So you can still get this console log statement. You still know what's going on. You can still add more console logs if you want, and they're gracefully they're just going to a no operation on networks that don't support this console log. They still consume a little bit of gas though, but that's a really nice thing. You don't have a step-by-step debugger as far as I know. I don't think there is something like this. And also in all your JavaScript files in the tests, you need to take care of deploying your smart contracts yourself, while you can still deploy them like in separate scripts, deploy the smart contract. So there is not like in Truffle, you have the migrations, which are taking care of the deployment of the smart contracts and the setup. And then in the tests, you basically just use them. You can still deploy them if you want, but use a clean room feature. So that's entirely different. It's a different approach. And I also think you don't have, because you don't have these artifacts, you basically have artifacts in Hardhat, but they are not the same artifacts as in Truffle. They work slightly differently because you have the ABI and you have the bytecode and everything, but you don't have an address management. So when you run npx hardhat, was it run network localhost, where is it, scripts, sample script, it will start to deploy the greeter, and it will give you an address, but you have to take care of managing this address yourself. As far as I'm concerned, that the last time at least I used Hardhat, it was like this, and I don't think that's changed. So there's no address management for different networks. Well, if you have a look into the build folder from Truffle for, let's say, the sample token over here, if you scroll all the way down to the network section, then you will find that Truffle is actually taking care of saving the address of the smart contract to a specific network. Now that one comes with a caveat, especially for test and dev networks, which have the same network ID. Then it gets sometimes a little bit messy. I had a couple of problems with that. It's not as clean as Hardhat, but it's very convenient. As soon as you go into larger development projects with a large ecosystem of smart contracts, I very much enjoyed having Truffle managing those, and we're doing that at Morpher. We're using Truffle exactly for that. But I totally see that Hardhat, because it's so clean and so sleek, and basically everything is managed with scripts and nothing is kind of interconnected. It's more like components with plugins. It has its benefits there for me as well. So pick your battles and see what kind of tools you have to win those. So how do we go about integrating our smart contracts now? Let me just delete the whole cache and artifacts folder. Let's delete the greeter. We don't need that greeter. And we just take our smart contracts, because solidity is solidity. We are going to change that one. We're going to add this over here. And then we are going to change our test, because our test is, we don't have a real deployment over here. Our test deploys and tests our smart contract. So why don't we get the smart contract factory for sample token? Then we are going to deploy our sample token. That is a sample token and talk, and it has what are we going to do here? Let's give it at least, let's say, 50 tokens times 10 to the power of 18. Yeah, this time we don't make the same mistake as the last time. And then, well, we obviously want to call this sample token. And then we wait for the sample token to be deployed. And we are expecting our sample token to have a total supply to be equal of 50 times 10 to the power of 18. Okay, let's just comment this out and see if this works. Let's just test it on network localhost. Oh yeah, of course we have to import, install our npm install OpenZeppelin /contracts. Let's just test this. And it's passing. That's perfect. That's interesting. Unrecognized contract. Let's see if we restart this, if this works then. Yes, now it works. So we have a contract call. It shows us everything nice and neat, where it is going to hook into the smart contract, how much gas and so on. Very, very useful. Okay, let's deploy our staking token. How do I get this address? Should be this address. Staking token, and then we are going to deploy it. And then the next thing that we're doing is we have to set up our permissions correctly. So we say const grant burn transaction is await SampleToken dot grant role, and that is await SampleToken dot burn a role for our staking token dot address await grant wait, and then we also want to set up the grant minter role let's just see if that works. That still works. And then we are going to stake 50 staking token dot 50 times 10 to the power of 18 and then we are going to wait for that transaction to happen, and then we expect our staking token balance of our accounts. Where's our accounts? We didn't import our accounts yet. Oh god, accounts is the HRE get signers. The ethers accounts is ethers get signers. So we expect our balance from the first account to be equal 50 times 10 to the power of 18. Perfect. Let's see if this test works. Oh. Wrong brackets. Oh, that's an accounts 0 dot address. Yeah. Yes, that works. So the next thing is we need to deploy that somehow. So we are just copying this one over here and pasting it over here, and we are not doing anything here. I'm just having a look where the staking token deployed to, and SampleToken deployed to that address. We already have minted everything, and we already have staked correctly. So why don't we just stop this whole Hardhat node, and then we are importing our key for the first account into our MetaMask. Just see if that works. So I have the Hardhat page here open. That account is obviously useless. Import account, it's another one. We have 1,000 ETH here. Why don't we run npx hardhat run network localhost scripts sample script. Oh, something didn't like me. What is that? Of course, we cannot expect anything here. Okay, it's from the tests. Okay, let's see if we can import our tokens. And why do we have only so little tokens? Of course our balance is 0, because we staked everything. So let's just stake a little bit less. Exit everything. Run the sample script. Open our MetaMask. What is baffling me is that we always have a different token address. So now I have some tokens, but I have nothing staked. Let me see the staking token. Fascinating. Let's just have a look at the console, and that is our sample token. Balance is 454. Which might have been necessary to address it like this, with the E. So let's just run everything again. Oh, that's an overflow now. Okay, let's just see if we can string that. That doesn't work either. Okay, normally you want to do this with big numbers and stuff like that. I don't want to do that right now. Let's just run the whole thing. See if we can open the console. See if we can interact with it. Yeah, it looks pretty good. And now let's just connect to a different network and connect back. And we have our 500 tokens and toke. That should have called STA, but maybe I made a mistake somewhere. No, I don't think so, that I made a mistake somewhere. I don't know, maybe something going on. But our staking token has now 50 and our toke 50 and 450. That doesn't make any sense. Oh, 50 and okay, yeah, that makes sense. So it's 50 times 10 times plus 18 zeros. Okay, that makes sense. But the name of the token still doesn't make any sense. But that might be a coincidence with MetaMask. But why don't we just have a look, because we can, right? Const staking token is await ethers get contract at staking token, and then the staking token address. Staking token how's it called? Symbol, right? Damn it. STA. It's the right symbol. Might be a glitch in MetaMask. Who knows? Anyway, that's basically everything that I wanted to cover for Hardhat. We have covered. So what have we done? Let's just quickly recap. First of all, we have our basic structure with the contracts, and if we compile them, they are becoming artifacts, and they are going to be in the artifacts folder. Well, in Truffle it's the build folder, here's the artifacts folder. We have no addresses. We have to take care of the addresses ourselves, which is fine. Doesn't have to be. We can test, and the tests are also clean room tests, more or less. They are clean room tests because we are going to Hardhat is going to compile the smart contracts, which is nothing super special, but over here we have to deploy them ourselves. So there's no what did I do now? How can I cannot. Okay. No deployment management. Okay. For the tests, which is good or not good, depends on what you like. Then we have scripts, and they are really the heart of Hardhat. With the scripts, you are going to deploy and configure your smart contracts. And then we also have a console, which is convenient, and we have a node which supports stack traces and Console.log. For Hardhat. Cool thing. Now with this, we can conclude that part, and we can move over to Foundry and see how that works in Foundry. The last framework that I want to get started with is now Foundry. It's the newest one, and I personally just used it for one sample try and read through this book, or this docs, book.getfoundry.sh, and I really like a couple of things with Foundry. Number one is it's super fast. That's number one. But it has a slightly different architecture than both Hardhat and Truffle. And what I mean by that is when you are importing stuff to Foundry, the dependencies, then it will actually do this with Git submodules, and it will not run any npm packages. So it's going directly to the source of the whatever libraries or whatever packages you want to add, and then it's installing those in the lib folder. The number two, which I really like with Foundry, is their tests. The tests are all Solidity tests, which makes sense. If you want to test Solidity, that you test it directly with Solidity. They also have the Console.log. I saw that somewhere over here. I think it's here in the Forge Standard Library overview. You have the the console.log stuff from Hardhat, and you have a neat way to actually influence the virtual machine, and you can do stuff on the virtual machine that they have, like set specific storage slots to specific values and so on and so forth. So it's really nice. And what I want to do now is I just want to get started with the exact same project that we did before. I want to run through the installation. I don't think I have it installed here in my WSL, so I'm going to install Foundry here. I'm going to create a new directory and run through that. And then we are going to import our smart contracts and run a simple test on it. So why don't we get started with that? So I'm back in my development environment, and I'm going to create a new folder, Foundry. And if you follow this, you can do this as well, and then just upload the whole thing to GitHub, to your GitHub repository, create a nice README over here, so that you have a kind of a showcase for recruiters you actually want to work with, the ones that are looking that you have done something in the area where you want to work. And so Foundry, I'm in this folder now, and I'm going to curl Foundry, and then there should be a Foundry up somewhere in the path. And if it's not, and you have to restart everything, then just run source and then your bash rc. So I'm going to run Foundry up, and then it's going to install Foundry. I'm going to download a couple of things, and then we can do, let's have a look at the README. First steps with Foundry init, and then hello Foundry, and then it will create a directory. Maybe I can do Foundry init period. No. Oh, Forge. It's Forge. Forge init period. So it's going to install our standard project structure or scaffolding into that folder over here. So if you compare this to Hardhat and Truffle, then a couple of things change. Number one is both in Hardhat and Truffle, we have the node modules folder. Here we have a lib folder, and it directly installed the Forge standard library, and it does everything with Git modules. So the submodule lib Forge standard is over here, and you see it's itself a GitHub repository, right? It's a submodule, and I like this very much. You can then update them depending on what you need. There's the scripts for the Solidity files. No, there's actually the Solidity files in the source folder, and the scripts are scripts for running those scripts. Let's have a look at those a little bit later. And then we have the tests, and they are having contracts that are called ending with test, and then functions which start with test, and they will automatically run those as tests and then basically assert this. So if you're running Forge test, then it should download the correct Solidity version and so on and run the test. And it's caching everything over here. So if you want to remove the cache, then you can just remove this folder or the files. So that's Foundry. And one thing that I would very much appreciate is if those were intercompatible. So if I could have Truffle for my smart contract deployment management, I could have Hardhat or Foundry for my test management, or having some additional tooling around that. Because I really like Foundry, especially with the fuzzy testing, and I also like Hardhat with the scripts, and I also like Truffle with the actual deployment management. I do not like Truffle so much with the testing. It's pretty slow, and I also don't like that they are deviating from the standard Mocha describe. They're going to have their clean room environment and so on. But it's kind of like, I don't know, it just doesn't feel right. It feels like you have to buy into another ecosystem. With Forge, you also have to do that, or with Foundry, you also have to do that. But it makes a lot more sense to me to have it this way. So I'm not that hesitant to actually buy into that ecosystem. With Hardhat, I don't know, it's like a mix between those two. And as Foundry also understands the console logs, maybe I would just go with Foundry in the future. So why don't we add the OpenZeppelin smart contracts? So we could do now forge install OpenZeppelin / contracts. Is it OpenZeppelin contracts? Oh, and then I have to sign in with GitHub. Interesting. Yeah, just sign in. Oh, I don't have OpenZeppelin contracts. So how are they called? Oh, they are called OpenZeppelin / Zeppelin OpenZeppelin contracts. Okay, let's install this. Forge install OpenZeppelin contracts. So we have our OpenZeppelin contracts now over here, and we can just use them as usual in our source code. So why don't we bring over our contracts, our SampleToken and our StakingToken contract over here. Delete this one. I don't want to have it in the test folder. I want to have it over here. And then we are also going to have a deployment over here. So let's see if we can build that. Forge build. Maybe I have to delete the cache over here. Let's try this again. No. What is the scripts for? Let's have a look if we are going to change this to the SampleToken script setup run, and then a new SampleToken with SampleToken talk, and we said 100 Ether. Oh, now it's starting to work. So let's rename this to SampleToken.s.sol. This is interesting. The script is not really mentioned in the docs of Foundry. So if I go to the Foundry book and see at the project layout, then there is no mention of the scripts, and the scripts actually make sense because their way of deploying stuff over here is to have Forge create, and then you go to, like you say, which kind of contracts you want to create. And if you have constructor arguments, then you have to give them over here the constructor arguments. And maybe it makes a lot more sense to have these scripts. It would just have been nice to see that actually in the docs somewhere. And I had a look if I can see that, but I didn't. So maybe that's a brand new thing. So obviously our smart contracts are not in at OpenZeppelin because that is the node module. So why don't we just remove that and go to the lib folder, OpenZeppelin contracts, -contracts, and see if this compiles now. Lib Foundry, lib OpenZeppelin contracts, token. Oh, they are here in /contracts. Okay, token ERC20. Okay, that is probably for the staking token. Doesn't like my. So, yeah, compiling 19 files. Let's see how long it's gonna take. I think simply from the feeling of it, it is much faster, first of all, than Truffle. If you go back to Truffle and type in Truffle Compile, I think it's all, then simply from the feeling of it, that is not 4.36 seconds. That is longer than 4.36 seconds. I cannot really, I don't have a timer here, but simply from the feeling of it, that is a lot longer. 1, 2, 3, 4, 5, 6, 7, 8, maybe 8 or 9 seconds. So let's go to Hardhat. npx Hardhat compile. Let's see how long that's gonna take. Nothing to compile. Is there a reset flag? Clean. Compile. 3, 4. Oh, that's okay. That's pretty much the same. All right, so they are pretty much head-to-head from the compilation time. So let's go back to our Foundry. And then we have to see how we can test this. So we have one script that deploys probably the sample token. I don't actually know what it really does. So why don't we just sample token is new sample token, and the other one is the staking token. And I really don't know what I'm actually doing here. I'm just guessing that this is the way how it's done, because I cannot find anything in the docs. Staking is new staking token, staking, and then the address of the token, and then the token dot grant roar. Was it the minter roar? To the address of staking, and the same with the burner roar. Let's see if that works. At least it's built. I don't know if it's really working. So why don't we create a test around that? So let's just rename this test staking token .t.sol, I guess. Staking token test is a test, and then let's test staking. Let's see if we're gonna run test, or it's still passing. I'm a little bit confused here. Maybe I can, I don't know, import the script inside my test, or maybe I can, it's injected, it's not injected somewhere. I don't know. Should I just import? Let's see if I import the script SampleToken.s.sol into this one, and I say this is test SampleToken script, and I make this one not here, but maybe over here. I don't know if that's gonna work, to be honest. But we can try. So can I get, let's see if I can use console here. Console.log token. Yeah, what if I can make this virtual and this one override here? And how did that with Console.log worked? Console.log should actually work if we are saying this is test and this is the Forge standard test library. So why does Console.log not work here? Well, let's import this also individually. Maybe it changes something. Okay, let's script this all together. Let's just set up the token over here manually. I don't know if that script is actually meant for doing that. So why don't we just take the whole thing here, set up over here, and then do the sample token setup here. Can we format this? So I format for solidity. Let's format this and then save it and then run it. Oh, and now we have to import the tokens, of course. And then we have to import the sample token.sol as well as the StakingToken sol. Oh, that is in source, of course. And I don't need to override anything here because we are not overriding something. I still cannot find console. So what am I doing wrong here? Type error, remember log not found or not visible after argument dependent lookup. Maybe it needs to be address from the token. Oh, now it can. And because the test passed, it will not show us the actual argument. So why don't we run VV, which I think will give you the logs of also the test that passed. And that one is the address of our token. Now this is fantastic. Now we can test the staking. So our test contract is the message sender during deployment. That means that our message sender should have all of the 100 ETH of the token balance. So we can assert equals the token dot balance of address. This is 100 ether, or 100 times 10 to the power of 18. So let's see if that works. Missed the semicolon. Fine, it doesn't. Why it doesn't work? Oh, wrong. Of course. How about now? It passed. That's perfect. So the next thing that we can assert is the staking balance of this address is 0 ether. And then we are going to, what are we going to do? We are going to staking.stake 5 of those tokens, and then we assert equal token dot balance of address. This is 95 Ether, and a staking balance of is 5 Ether. How's that gonna work? Fine. Perfect. Now I guess we can do a lot more things, but I think this video should give you a really good overview of how things are working with Foundry versus Hardhat versus Truffle. And if you want to know more, then I might gonna do a follow-up video. Also make sure if I make any mistakes, or if you have a different opinion or I miss something, just leave a comment below, or join our Discord, our forums, our community, and get in touch. Yeah. Okay, now we tested Truffle, we tested Hardhat, and we tested Foundry. I personally like the following things of each one of the frameworks or toolkits, and there are a couple of things I dislike, and I want to list the things that I kind of really like. For Truffle is I think the oldest one of those. I mean, it's the oldest one of all of the toolkits that I used. I use Truffle since version 3. I'm very comfortable using Truffle, and you probably saw it in the video. And there are a couple of things that I kind of like, especially because also with the companies that I work for, they deploy to several different chains, and there is smart contract address management. And if you work in a development environment, and if you work with other people, it is always very nice to have the framework or the library itself take care of the address management. So that's what I like with Truffle. Address management. Sorry, my handwriting. I'm using this tablet for the first time. There's the other thing with Truffle, which made my life a lot of times super easy, and I wish they were pushing more hard towards that. That is the console. And it's not so much the console itself that is cool. Hardhat is a console, and for Foundry you don't even need a console because your bash is the console. But because they use the Truffle contracts, the abstraction library where this address management comes in. So you can at the end just do await then your contract dot deployed. Can I just delete this? Oh, okay. Should be brackets open, brackets closed. And that will give you a new instance. And that is so cool, because then you can directly work with that instance. You don't have to take care of any addresses that are managed somewhere else. You don't have to put them somewhere. You don't have to get them from any secret store or from any environment variables or whatnot. It is just there. And then there are two more features that I really like with Truffle. That is the new dashboard. I have a separate video about that, which makes it super handy to deploy via MetaMask or any kind of other injected web-free provider, because that one will open a website, and then you can use your Chrome plugins or whatever it is to inject a web-free instance or a web-free object, and then it will use that to deploy stuff from your console. I found this super handy. That is one of the killer features for me. And the other one, I don't have any space here anymore, is the debugger. And I don't mean to use it for development. I mean the debugger can get any transaction hash and just debug stuff. And that one is another killer feature for me. What I don't like with Truffle is it feels very heavy. It feels just like very heavy. If you compile stuff, if you compile smart contracts, or if you are testing, if you write unit tests, oh God, it takes forever. And it really is no fun. It kind of encourages you not to test your smart contracts because it's so heavy. But this is where the other frameworks come in. And I think it would be nice to have like a mix of those. Like, I don't need a framework that can do everything. And I need just a few things or one thing per library that does it really well. And this is now where Hardhat and Foundry came in. Now, Hardhat obviously is fast. Hardhat is super fast. And I really like that. Hardhat has a huge community now. And a lot of plugins. It even has plugins to go back to make it Truffle compatible. And you can use it with Web3, or you can use it with ETHS. So big plus. Big plus. Big plus for me. Hardhat is also super fast for testing. Big plus. Fast is always important, because if you have a bad experience as developer, then you become sluggish. You start to make mistakes because you don't want to finish it. The whole workflow just feels like it's slowing you down. And I don't like that with Truffle, and I like that very much with Hardhat, that it is fast. It is so freaking fast. What I don't like with Hardhat, and I'm not going to list that here, is the kind of deploy management. I do get that it can be done with scripts, and you can, do with your scripts whatever you want, but I don't need that kind of freedom. I never felt that I need that kind of freedom. All what I need is something to take care of that, and I didn't find a plugin. And maybe you see one, and you can leave me in the comments below a better way to do that. How to get Hardhat to actually manage all the addresses for different chains and for different development environments and so on. The other thing which I really like with Hardhat is the internal chain, this node plus Console.log. It's not a super killer feature for me, but because it's so fast, it becomes really handy with development. So that one is like the number one thing why I would love to have Hardhat during development, and then love to have Truffle during deployment. And then so in the previous videos where I always said I'm gonna do prototyping in Remix and then I bring it over to Truffle, I think I'm gonna revise that. I think it should be like really rough prototyping in Remix, and then bring it over to Hardhat, and then do all the unit tests and all the testing and make it really stable, and then use Truffle for deployment. At least for me, that would be a workflow that I can imagine works. But now I tested Foundry. So today, when I recorded the video, was kind of like the first test where I really tested Foundry. I was reading through the docs, I played a little bit around. There are a few things that I really like with Foundry. First of all, it's also fast, like really fast, because it doesn't have this overlay of JavaScript. The other thing which I like is the dependency management. Dependency management. That is like a big plus. That is super awesome for me, that it is directly downloading the packages from GitHub. And then I also like that, I think they came from, how is it called? Dapperland or something, the testing framework. So testing is done in Solidity, but that's not, I mean, Hardhat and Truffle can do tests in Solidity. That's not the big plus. But the big plus is the VM the VM influence. So you can do prank, or you can do also the Console.log, the same one that is over here. No, not here. Here. So those things I think are a big plus, and I might be inclined to think that there will be a lot of people shifting from Hardhat to Foundry. But both of those libraries or frameworks or toolkits cannot do what Truffle actually does. And that is more for enterprise, which I really like. And that is more, I don't know, for development, I think. Yeah, that's my take on those things. Let me know in the comments below if I missed something, if I understood something fundamentally wrong. One thing that I don't like with Foundry, which I just found out, is that their docs are not up to date with actual functionality. I think Truffle lost a lot of users, or the Solidity ecosystem or the Ethereum ecosystem lost a lot of users by not having documented stuff that actually happens in their software. So it's always a kind of a toolkit or a framework is ahead of time, and then suddenly a new breaking feature pops up, and then you don't know what's going on because nobody tells you unless you're in some sort of GitHub channel, Discord, or somewhere directly in the community. I mean, if I want to use one of these frameworks, then I don't want to have to go to a community to actually find out how it works. It should just work. So I don't know. That is like a big question mark for me now, how that's going to work in the future. But I will definitely give Foundry another try. Hardhat has its place and is loved by a ton of developers, and Truffle still has a ton of developers actually using it. But it has a couple of things that kind of need improvement, or maybe they can just take out the whole testing. There is no need to have the full testing suite in Truffle. Just leave that to other frameworks. I mean, why not? Just do one thing, but one thing great.
Well, that's it. Thanks for watching. I hope you found this video useful. If so, then subscribe to this channel. It's only $499 a month. Just kidding, it's free. And hit the bell icon if you want to have more of these videos. Or, I don't know, check out one of these videos that are popping up probably right now on the screen. And I will see you in the next one. Don't forget, you can get all of this content also on Ethereum-Blockchain-Developer.com.